Ladies and gentlemen, we have chosen to do a cost-benefit analysis on the Mount Wellington cable car project. Before we tell you why we think the crippling debt is a good enough reason to consider not building the cable car and instead investing in an alternative project on the mountain, we'd like to tell you how we arrived at our conclusion. Even before that, however, in case you missed it during our first presentation, we wanted to go over the basis of our project once more. The Mount Wellington cable car is going to be, shockingly enough, a cable car on top of Mount Wellington. There will be 3 stations, one at the current location of the Cascade Brewery, a second halfway up the mountain, and the final terminal at the very top. For this project, we have been forced to fill in numerous data gaps stemming from 2 primary issues. Cost-benefit analysis about cable cars are harder to find than you would think, and the Mount Wellington Cable Car Company, which as its name suggests, is not publicly revealing their information. We emailed the cable car company, but no response. Moreover, when asking a macroeconomic consultant whether we would be able to receive or see the cable car company data, he indicated he was barred by confidentiality agreement he had signed. He explained that because it was a private project for commercial reasons, it was very unlikely we would be able to access or receive any of their information. As such, we have had to scour the globe for statistics we can use to extrapolate possible numbers for the Mount Wellington Cable Car project. We have looked to South Africa, New Zealand, Hong Kong, and even as far away as Scotland for information on similar projects. We found environmental impact assessments, financial costs and benefits, annual reports, construction documents, and macroeconomic impact reports, all of which we have gathered data from to fill the gaps in the holes. It should be noted that the information pertaining to a funicular railway in Scotland was provided by Dr. Tinch, even the staunch patriot. In particular, in receiving a small amount of data from a macroeconomic impact report on the cable car, which Paul St endorsed, we were fortunate enough to have a meeting with Phil Bailey, the consultant who had written the report. The report found that the cable car would boost Tasmanians' economy by around 99 million. Phil explained that to calculate this, he used the data given by the cable car company, which as stated earlier, we weren't allowed access to, and the ABS data which helped calculate the multiplier effect. The multiplier he used was deliberately conservative with a value of 1.7. This showed the amount that would be spent in the economy compared to the amount of money that would be spent if the project did not go ahead. I'll now pass you on to Junwei.
Alright, so unsurprisingly, this has led to a number of data gaps, in particularly calculating quite small environmental and virtual costs such as clearing a couple of trees, where the trees will be any otherwise employed person who will be employed by the cable car, and the price elasticity of consumers for the cable car. We also need to calculate the value of greater access to recreational activities like mountain bike riding, the cost of the land for the construction of the cable car, and more accurate maintenance costs. The estimated lifetime of the cable car until the equipment needs to be replaced and still needs to be found. And a sensitivity analysis still needs to be done. However, we imagine conducting the sensitivity analysis should be no problem. To fill the data gap of any employment benefits, we will be researching how much indirect employment there will be, as well as if there is any information showing the proportion of unemployed persons typically employed by tourism projects. To calculate the price elasticity, we are currently looking into similar cable car developments, comparing the amount of passengers they receive at their given price, and dividing by their length in meters and populations of the town where they are located in. Use these different numbers, we can calculate the elasticities for a linear demand curve. Although we realize a lot of assumptions are involved here, it will give us a ballpark estimate of the demand, elasticity, and optimal price. Finally, to calculate the purchase price for the land, we will be checking if there is available anywhere or land values of comparable sites. Calculating the quantifiable social and environmental costs is proving a challenge due to the uncertainty surrounding the effect the cable car will have on the environment. As it currently stands, the cable car will likely not leave a sky in the terrain and will be built over the existing trees, and as such, the big issue at hand will be the construction of a large observatory, visitor center, and restaurant on top of the mountain. One of the possible costs may be the removal of the pinnacle, although the effect on the skyline of the city and the view is not easy to be quantified, yet seemingly marginal at best. In accordance with statements made in macroeconomic impact assessment of the project, the creation of the cable car should raise revenue throughout the city. 3 primary visitor types have been identified, such as mountain bikers, local residents, and cruise passengers. Of these, the cruise passengers would have the largest impact upon the economy. They spend approximately $100 each day on average in Hobart, and up to $300 per day in cities such as Melbourne or Sydney. Local residents were projected to react indifferently to the project. They may initially ride the cable car, but spending on goods such as souvenir items is predicted to be insignificant, due to the fact that they already know what their city has to offer, or at least we hope they would. It is really not a very big place. Now I pass it to Peter for the results.
Determining financial costs and revenue, such as employee wages and construction and maintenance payments for the cable car, as well as ticket prices, were calculated using average prices sourced from other cable cars. These included the Corunda Sky Rail in Cairns, or near Cairns, Tableway Mountain Cableway near Cape Town, the Skyline in Rotorua, and the Wellington cable car in Wellington, New Zealand. We learned to label our Wellingtons accordingly after group discussions began to get muddled, and we realised that our cable car couldn't possibly afford to charge $7 for a return trip. The aforementioned costs, particularly construction, will be calculated in metre increments. We'll be using complicated mathematical concepts, such as Pythagoras' theorem, to calculate the distance the other cable cars run for relative to their construction costs. The construction costs for the Mount Wellington cable car also include the purchase of land on Mount Wellington in the Wellington Park, specifically for which laws are being drafted. Although these may not be released in time for us to enter them into the CBA, we will have to, in which case, estimate them based on land prices around the Hobart area and similar areas around the globe. Assumptions we are currently making in regards to our calculations are as follows. A 7% discount rate in accordance with the estimate provided by Duggold in our workshops. A 15-year lifespan for the project before significant maintenance or infrastructure will need to be taken into the account, although this is subject to change as we need to do more research on that issue. Currently, projected visited numbers from the Mount Wellington Cable Car Company, assuming that maintenance costs are relatively equal to that of the Wellington Funicular Railway, which uses cable car tracks, and a high initial ticket demand due to a novelty effect that will decrease over time until it eventually plateaus. The price per tonne of greenhouse gas emissions has been calculated as the price per tonne when the carbon tax was in place in Australia, and the amount of long-term employment is simply the amount the company says will be employed. It should be noted that plenty of this data is quite uncertain, given that most of it is simply based off the cable car company's claims on their website, which may be suffering from optimism bias, as well as quite unrealistic assumptions for costs such as that we have made, such as maintenance, where there is an absence of information and we have had to fill from a somewhat comparable source, but quite different nevertheless. The optimal price of reducing CO2 emissions may also differ from Australia's carbon price, given the conflicting views on the cost of climate change. Now for the number crunching. The maintenance cost will be, as we have estimated so far, $2,403,794 a year. Number of fixed employees, 80. Marketing costs decreasing over time, but initially at $408,584.40. The estimated number of passengers, once again, decreasing over time and plateauing, initially at 408,584, most of which comprise of expected tourists. Greenhouse gas emissions, as previously stated, that price will be priced at $15, and the average adult return trip ticket will be priced at this stage $20, although obviously once again all these calculations are subject to change. Currently our calculations are somewhat at a preliminary stage, since we are hoping to find more data that may solidify our current estimates or display whether they are above or below expected price levels. Particularly in relation to ticket pricing and visitor numbers, we are aiming to calculate the price elasticity of demand, and if our figures differ from those of the Mount Wellington cable car, we will be noting that in our findings, but not relying upon those numbers too much, since the research carried out by the company is also presumably more detailed and has data based on findings from surveys or community polls they have conducted. Their employee wages will also be calculated using average salaries from hospitality and tourism industries within the state, and these will be used more effectively to calculate the cost of running the facilities. Accounting for all gaps in our current calculations, however, the cost of the cable car is expected to exceed the revenue generated by around $58 million in net present value over 10 years. We do acknowledge that as it stands, our facts and figures leave much to be desired, and we certainly did not expect such strong findings. But if our numbers are anywhere near the real cost of the project, it seems abundantly clear why information about the project is being kept secret. Reputations and millions of dollars is a great incentive to stay quiet. Given our current project, if indeed the project does get off the ground, pigs may fly. We thank you for watching our presentation and welcome any and all feedback you have that can help us improve our CBA and fill in our data gaps. In particular, we would like to note that any assistance on calculating accurate figures for wages and salaries would be appreciated. But we will be sure to take into account everything you say and use it to improve upon our existing project. Thank you, and I'm out.